There you go. Hello, my name is Bill Donahue. I'm a former executive director of science and executive director of monitoring in Alberta Environment, and I'm doing a repeat of the presentation to the Alberta Coal Policy Committee that I gave on behalf of the Livingstone Landowners Group on the impacts of coal mining in the upper McLeod River watershed on downstream water quality. And the data that I've analyzed and that I'll be talking about and showing are from Alberta Environment. They had a monitoring program that they began in that part of the woods in 1998, and it continued until 2016. And they had sampling sites upstream and downstream of 3 different mines. The Cheviot mine, the Cheviot mine, the Luscar mine, and the Greg River mine. And the Cheviot mine is in the headwaters of the McLeod River, on McLeod River, or essentially beside the McLeod River. The Luscar mine is on Luscar Creek, which flows into the McLeod River, downstream of Cheviot, and the Greg River mine is further downstream on the Greg River, which flows into the McLeod downstream of the other 2 mines. And this monitoring program was designed specifically to identify effects of coal mine operations on downstream water quality. So they sampled immediately upstream of the mines, either on the river or the tributaries, and downstream. And they also had a couple of sites further downstream along the McLeod River, but I'm just describing the changes from upstream, immediately upstream to immediately downstream. And so it's a subset of the data, and what I've looked at is data that only were sampled on the same day, upstream and downstream of each mine. So a little background. Mining began at the Luscar and Greg River mines in 1969 and 1982, and reclamation began within a year or 2 after both of those mines opened. Active mining ceased in the Greg River mine in 2000 and Luscar mine in 2004. And while operations at Luscar mine ceased in 2004, the processing plant and the site remained in operation for processing coal from the Cheviot mine, which opened in 2005 and continued in operation until 2016. So the year after the monitoring was ceased, as well as the closure of the Cheviot mine in 2017, 60% of Luscar mine's footprint was reclaimed and 99% of Greg River's mine was reclaimed, though not certified by the AER. And so what I'm describing is, in the case of Luscar and Greg, at least, the changes, persisting changes in water chemistry downstream of these mines are despite the fact that more than half and almost the entirety of these mines' footprints were reclaimed to the standards that are expected of the companies, although again, not certified. And so that's an important thing to consider, especially in the context of a company claiming, oh, well, once it's reclaimed, the presumption is, we'll be done. It'll be back to normal. So to assess the downstream impacts of the mines on water quality, as I said, I selected pairs of samples taken on the same day in both upstream and downstream of the mines from Alberta Environment's 1998 to 2016 data set. In this way, I assessed the degree to which concentrations downstream of coal mines change relative to concentrations at undisturbed sites that were used as references upstream of the mines. And thereby avoiding problems introduced by sampling on different days or different stream conditions. And so then I basically divided the concentration downstream by the concentration upstream. So if they're the same number, there's no change, then it will work out approximately 1. If the concentration downstream is higher than upstream, the ratio will be greater than 1, and if the concentration of something has declined downstream relative to upstream, then the concentration ratio is less than 1. And so as you can see here, you know, many of these, this is a whole bunch of different heavy metals, nutrients, basic water quality parameters, as well as some other things. And so as you can see, there's a wide range. Numbers are very high in some cases and low in others. And so this is, there's a table in the report we provided to the Cold Policy Committee also. And so, for example, you know, many of the compounds have significant negative indirect environmental effects in aquatic ecosystems and food webs, but most concern in response to coal mining relates to selenium contamination. And that's what most people are talking about and hear about. But there are all kinds of other chemicals that have significant or can have significant impacts in aquatic systems, just in addition to selenium. So the monthly water quality monitoring reveals significant increases in average concentrations of a wide variety of chemicals. For example, selenium among the 3 sites is 6 to 14 times higher downstream of the mines than upstream. Sodium 8 to 77 times higher. Nitrogen, and it's mostly nitrate with a little bit of nitrite, is 5 to 38 times higher. Chlorine 3 to 31 times higher. Arsenic is 7 to 8 times higher. Sodium 8 to 80 times higher. And so keep in mind, this is the number of times higher, not a percent increase. So cobalt in Luscar Creek isn't 353% higher. It's 353 times higher. So essentially 35,000% higher. So here is a graph of these paired samples and kind of, you know, either for the 3 mines. So upstream and downstream of Greg in the squares, Luscar, upstream, downstream in the circles, Cheviot in the triangles. Red is downstream, blue is upstream. And so generally what you can see is concentrations are much higher downstream than upstream. And this is an exponential scale, keep in mind on the left-hand side. You know, so ballpark, the concentrations upstream are generally bouncing around less than or greater than 1 microgram per liter, which is the alert level for the protection of aquatic life that Alberta Environment uses to kind of create a red flag where they need to start investigating or figuring out what's going on and how to prevent it from getting above the 2 microgram level. And of course, you can see downstream in all the mines, the majority of the sites, the majority of the samples are much higher than the 2 microgram per liter or the 2 parts per billion concentration that's required to protect aquatic life. And I'll highlight here that also, at least from these sampled paired data, there's no statistically significant decline in selenium concentrations downstream of Luscar through the period of monitoring from 98 to 2015, or in Greg River between 2001 and 2016. Despite that, the mine in Greg River closed in 2000 and Luscar closed a couple of years after that. And then Cheviot, you know, started relatively low and seemed to increase in the period that it was in operation. So downstream of Luscar and Greg River mines, 97 to 100% of paired samples exceeded Alberta standards for protection of aquatic life for selenium, which is 2 micrograms per liter here. So almost all the samples downstream of Luscar and Greg, substantially less at Cheviot, and then similar patterns for chlorine and aluminum at both chronic and acute levels. Maximum concentrations of selenium in Luscar Creek downstream of Luscar Mine were 40.6 micrograms per liter. And keep in mind that the protection of aquatic life limit is 2 micrograms per liter, so more than 20 times higher. The max in Greg River Mine was 11.9 micrograms per liter, and the max downstream of Cheviot Mine was 6.2 micrograms per liter. So all far higher than the 2 micrograms per liter above which harm can be expected to aquatic organisms. And while concentrations of selenium may be naturally high in Luscar Creek, which is showed by this reference upstream numbers, they are not zero. And to a lesser extent, Greg River, based on elevated concentrations and the frequency of exceedances of guideline limits for selenium and the other compounds that you can see in those reference systems. The water quality upstream of the Cheviot mine is generally much better in the reference site, and consequently there are no exceedance of the selenium levels. So it varies, naturally there's probably higher selenium in some of these systems because, well, you mine coal where there is coal, and if there's exposed seams or groundwater inputs coming in from oxidizing coal deposits, you would expect higher selenium concentrations and some of the other metals. But ultimately, continuing contamination downstream of the West Central Alberta coal mines almost 2 decades after their closure is consistent with what's been documented in streams downstream of mountaintop coal mines elsewhere, including in the Appalachia region in US, almost 2 decades after their regulatory reclamation was completed. So this is not, while perhaps disturbing, it's not at all unusual. This is pretty typical for what you see downstream of coal mines, including up to decades after their closure. So, as I said, most people talk about selenium, but sodium is an important factor as well, because ultimately it has an impact on water quality for irrigation. And this may be of potentially real significance in southern Alberta, particularly in the Old Man River watershed. Now, obviously, in the upper McLeod, which flows into the Athabasca River, there is no irrigation agriculture up there. But I worked up the data just as an example of what you can see downstream of these mines. And if these mines were ported into the headwaters of the Old Man, the issue then becomes apparent. Now, significant shifts in downstream quality of irrigation water have been documented elsewhere downstream of coal mining and other types of coal development because of changes in specific conductance or the chemical balance between sodium, calcium, and magnesium in water. And that's because the typical irrigation water quality factors that they look at are either a combination of sodium, calcium, and magnesium and how they balance, or generally more broadly looking at specific conductance, which is a measure of kind of the electrical conductance of water based on its chemistry. Now, coal mining in the McLeod River headwaters resulted in a 77-fold average increase in sodium concentrations downstream of both Luscar and Greg River mines, and more than an 8-fold concentration increase downstream of Cheviot mines, with only slight changes in calcium and magnesium. And so this is one of the sort of factors that are assessed for irrigation water quality. It's called the sodium adsorption ratio, and it's just a calculation based on sodium, calcium, and magnesium concentration. So if sodium goes up at a much disproportionately greater manner than calcium and magnesium, you see an increase in sodium adsorption rate. So for Alberta Environment Standards for sodium adsorption ratio, which I'll refer just to as SAR, water with an SAR of less than 5 is considered safe for irrigation use. SAR greater than 10 is hazardous for irrigation use. And SARs between those levels are considered possibly safe for irrigation purposes. But I would say, you could easily say it means it's also possibly hazardous. Now, here is what you see when you look at the SAR for Luscar, Greg River, and Cheviot upstream. Luscar mine, the average increase is 5.4 units. And keeping in mind that anything above 5 is possibly unsafe. So on average, that means the water downstream of the Luscar mine has switched from universally safe, not much above 0, very low, much less than 1, to on average greater than 5. So in many of the samples were into the possibly safe or possibly hazardous range. Greg River mine, the average increase was 2 units. In the Cheviot mine, 0.8 units, and increasing over time. And I'll point out that none of the samples in the Greg River Cheviot mine exceeded that 5 units that indicate a shift between safe and possibly hazardous, but they all did demonstrate a decline in the water quality from the perspective of increasing SAR. Now, specific conductance, similarly used by Alberta Environment as an indicator of irrigation water quality. Less than 1,000 microsiemens per centimeter is considered safe for irrigation use. Greater than or equal to 2,000 is considered hazardous for irrigation use. And values between those 1,000 and 2,000 levels are considered possibly safe or possibly hazardous. And similar patterns in Luscar Creek. You can see on average, there's an 82% increase, an increase of more than 400 microsiemens per centimeter downstream as compared to upstream when sampled on the same day, putting a lot of the samples into the possibly hazardous range. And in Greg River, the increase in conductance was 94% on average, an increase of 348 microsiemens. And unlike with the SAR, in some cases, the water quality downstream did shift from safe to possibly safe or possibly hazardous downstream of the mine. In the Cheviot mine, there was an increase of 32%, a little over 100 microsiemens per centimeter. So looking at that, basically, in the McLeod River watershed, conductance increased substantially downstream of all 3 coal mines. And in the case of Greg River mine, it shifted to possibly hazardous 8% of the time, and downstream of the Luscar mine, it was 54% of the time that it was of questionable quality for irrigation. Similarly, the SAR also shifted, and top is conductance, bottom is SAR. So in the Luscar River downstream of the mine, it switched to possibly hazardous 61% of the time it was sampled. And so again, if this sort of thing occurs in the headwaters of the Old Man, well, the question then is, what are the impacts or what are the risks to downstream irrigation districts and the farmers that use the irrigation water? And the reason that this is of importance in terms of sodium and calcium and magnesium, when SAR increases, it decreases the porosity of the soil, and so the ability of water to move through it declines. And ultimately what that means is then it converts the soil into a state that is of less value, I guess, to irrigation, and crop growth is subsequently affected. Now, I'm no expert in this, but certainly the people at the irrigation districts or other farmers and everyone else would be able to speak to what this really would mean if this happens in the headwaters of the Old Man. In addition to the direct toxicological effects of selenium on, it's well known in terms of fish, it also, coal mining affects aquatic invertebrates. 2011 survey of invertebrates, benthic invertebrates in reference streams and downstream of these three mines in the upper McLeod, as well as BC's Elk River, which no doubt most or many of you have heard about in terms of the downstream effects on fisheries and the problems with water there. There were significant declines in density and diversity of mayflies, stoneflies, and or caddisflies that corresponded with the degree of physical disturbance caused by the coal mines. That included sedimentation, calcite formation, and just as a reminder, mayflies, stoneflies, and caddisflies are not only a group of invertebrates that are very commonly used to indicate changes or the state of the quality of water. Basically, the more of these things there are, the better the water quality, the healthier the systems are. But they are also our key food for trout. And so if anyone's a fly fisherman, many of the flies that are probably used in the headwaters are designed to look like some of these invertebrates. And so it's particularly important to see those declining downstream of these coal mines in the headwaters of the McLeod. And I think it's safe to conclude that similar changes to communities will likely follow downstream declines in water quality, increases in physical disturbance that no doubt will be caused by new coal mining in southwestern Alberta. Again, because these kinds of changes are seen universally downstream of coal mines, and I don't think there's any reason to think that somehow it will be different just because it's happening in Alberta. Now, as well, it's a significant risk to downstream fish, metallurgical coal mining. And metallurgical coal mining in particular, metallurgical coal is particularly high in selenium, and coal mines of metallurgical coal release particularly high amounts of selenium. So in the McLeod River Basin, you know, a year after they started water quality sampling, they also sampled rainbow trout eggs as well as female rainbow trout fish mussel or mussel, and both were positively correlated with water concentrations of selenium. At undisturbed reference sites with low concentrations of selenium, the lowest concentrations in trout eggs and fish mussel were found, and the reverse in terms of high concentrations. Highest concentrations in water, eggs, and fish were found downstream of the mines. And modeling of food web effects at the time predicted that there would be negative effects on fish species in these systems based on toxicological and kind of factors. And those were confirmed when they did toxicity studies on larval rainbow trout or small fry in the lab. And I'll point out also, within 2 years of beginning water quality sampling, they identified in Alberta environment that water concentrations in selenium were more than 10 times higher than the limits needed to protect aquatic life. So, you know, while perhaps surprising when they went out and looked for it, there is no surprise, should be no surprise in Alberta environment or AER now that these systems are super high in selenium. In 2011, some researchers from the University of Lethbridge returned to these systems, and they did detailed surveys of the aquatic food web, including the habitat, as well as algal and invertebrate biofilms, invertebrate organisms themselves, and then young rainbow and brook trout. Average selenium concentration in mussel of the rainbow trout downstream of the mines in the reaches of these streams exceeded levels expected to cause larval deformities. And they did see that up to a 5-fold increase in rainbow trout mussel selenium concentrations corresponded to a 93% decline in total fish biomass. So total fish biomass, basically, if you take the number of fish you catch and the size, and you kind of multiply them, that's the size or the weight, that's the total biomass. So when you see a 93% decline, it likely means there are far fewer fish and most likely of much smaller size. So basically 93% less fish, corresponding to increases in muscle selenium. And that, of course, was downstream of the mines as opposed to upstream, where it was unaffected by mine. Selenium exposure was also the only strong predictor of total fish biomass in each reach, in both reference and mine-affected sites. And so, as I said, they did a survey of all kinds of water chemistry, habitat factors, and quality, and they were unable to create a habitat prediction model for rainbow trout. The only factor that explained the changes in fish biomass for rainbow trout was selenium. I mean, it doesn't get much more compelling than that when you do a survey out in the wild. Now, metallurgical coal mining in the headwaters has clearly caused long-term harm to downstream aquatic ecosystems in terms of the invertebrate communities, in terms of the fish. Selenium and other chemical concentrations increased to biologically and ecologically hazardous levels almost immediately after open, as I said. And it was discovered within the first year or two of monitoring. For Cheviot mine, though, as you saw in those upstream downstream comparisons, pretty much as soon as the mine started operating, the concentration factors jumped downstream. Then during the mining operations of all three mines, and then of course after the closure of Greg River and Luscar mines, concentrations of many of these chemicals, including selenium, remained exceptionally high, and reclamation did not appear to substantially change that. So these sorts of persistent major negative downstream impacts, as I said, are routinely reported wherever there's coal mining. That's in the US, in Australia, China, Europe, across the border in BC, and also already occurring, and evidence of which I've just shown you, in Alberta. And I would think these impacts should be a cause for great concern in relation to any new metallurgical coal mining that's considered planned or approved in the headwater regions of Alberta. So that is the end of the presentation. And so it's important to keep in mind that, as I said, this was well known for the entirety of almost 20 years. And when anyone talks about the strength of the regulatory system or asserts that they are protecting the environment or these headwater systems, the data shows that, well, they didn't do that in the past. I mean, these concentrations of selenium were exceptionally high for the full period of monitoring. And even though 2 years after they started monitoring, they saw these really high concentrations and identified that there were serious harm being caused to fish, Cheviot mine was still approved and still opened. Now we've got the 3 mines going, all of these impacts clearly evident, and they approved and opened the Vista mine downstream of all of them. So it calls into question really whether either they are applying the laws and regulations as they're intended, or alternatively, that they're simply too many holes and regulatory discretions that allow this kind of thing to persist. I mean, but ultimately it clearly says that these sorts of significant downstream impacts really aren't a factor of any significance when it comes to whether or not to approve these coal mines in Alberta. So that's it. Thank you.